All right, well, 2 o'clock. I think we're ready to get started. So, Christian, Kara, do either of you have any questions before we jump into the excitement that is today? All right. Okay. Well, as usual, if you have anything that comes up throughout, feel free to break in and we'll go with it. But we are going to do 3 sections today. So we're into, the end here. You finished exam 2 last week. Those are graded. Grades are updated. Everybody's doing pretty well. And so we have, the last bit here. The first 4 sections are all based on the financial piece. So we get through 3 of the 4 of those, which means next week is Thanksgiving. I think I might make a separate video introducing the 3rd project, and I'll post that later on. Just because if we wait until after Thanksgiving to talk about the project, that really only gives you like 3 weeks. And not that it won't take you 3 weeks, but I know the end of the semester gets crazy. So I'll make that video to introduce the last project so that you guys can watch that at your own pace. And if you want to start it over the break of Thanksgiving, you can, but you don't have to, right? But that would give you an option. So anyway, so today we're going to do 3 sections, 19, 20, 21, credit cards, interest, and loans. You do have an Excel assignment that goes with these sections. I do have a video for it. I will post that video in the announcements when I post the live session of this. You've got a quiz, a discussion board, and that's it. So relatively, I don't want to say an easy week, but it seems like for doing 3 sections, there's not a whole lot to it. Next week is Thanksgiving. Tuesday is a non-class day because of Thanksgiving break, fall break, whatever you want to call it. So no class next week. I will be on my computer off and on over break. So if you're working on things, you can let me know. I'll answer questions, that kind of thing. So let me know if you have questions. We'll go from there as usual. So let's go ahead and jump into section 19, credit cards. So I don't know how much experience the 3 of you have with credit cards. Some are great, some are not so great, depends on your experience. But credit cards and a lot of other things in the financial world really depend on your credit, right? So a credit score is how they determine whether you have good or bad credit. And you get that credit by having loans and paying your bills on time. And really carrying debt. Being able to have debt and manage debt is a great way to build your credit. You don't want to jump into $100,000 of debt really, very quickly, but a small loan that allows you to prove that you can make payments on time is a good way to build your credit. If you have good credit, you will have lower interest rates on credit cards, car loans, home loans, that kind of thing. If you have a lower interest rate, you're going to pay less over time than if you have a large interest rate. Anyway, with credit cards, we're going to talk about some different fees, the finance charge, which is the interest on your credit card, and the APR. So do any of you know what APR stands for? That's what we're going to start with. APR. Nothing. Okay. Excuse me. The APR stands for the annual percentage rate. All right. Basically, this tells you how it's based off of how much interest, right? That's how the interest is based off of the APR. So this is given to you as a percent, and you can find out how much interest you're going to pay. Now, the key word here is annual. And if you think about when you make a payment on either a credit card or any kind of loan, do you make annual payments? No, monthly. Very good. So that's kind of a key thing that you want to think about, not just in this section, but in all of the sections, that we're dealing with financials. So we have an APR, but we don't make annual payments. So how do I take an annual and turn it into monthly, as Kara mentioned? Divide by 12. Exactly. So for most of the pieces here in the next couple sections, when you see an APR, you're going to need to divide it by 12 because we want to turn that annual rate into a monthly rate. So that's kind of the big key here. All right, let's go ahead and move into our first piece. So on a credit card, if you have a carryover balance, right? So basic world of credit cards. If you put things on a credit card, you have a grace period. And if you pay it off in that grace period, it's usually at the end of the month. If you pay it off, you have no fee, no interest, no finance charge. However, if you carry a balance over to the next month, you will pay a finance charge. So in this first example, we are going to pretend that we have a carryover balance of $1,200. Well, if I have a $1,200 balance on my credit card, that is what my interest is based off of. So we take our APR and we turn that into a monthly. So as Kara mentioned, we're going to divide it by 12. Well, remember, to play with the percent, you first have to change it to a decimal. So I move my decimal 2 places to the left to get 0.1899. I divide it by 12 to make it a monthly percentage rate, and then I multiply by the carryover balance. We are dealing with money, so we want to round to the nearest penny. So can anybody find the finance charge on this particular credit card? $18.99. Exactly. And, you know, that is coincidence that the APR matches the dollar amount. That is purely coincidence. It's the $1,200 that does it, right? $1,200 times 12 divided by 12. That's why it works like that. But yeah, so you would pay roughly $19 in interest. So that's added to your bill. You pay an extra $19. You're giving the credit card money with these finance charges. Okay, I want you guys to try one. Just find the finance charge on an $800 carryover balance if your APR is 26.99%. $17.99. Exactly. So we did the change the percent to a decimal, divide by 12, multiplied by your carryover balance, and when you did that, you get $17.99. All right, so that's kind of the first key to figuring out the credit card business. All right, now we're going to kind of work through this first table here, and we're going to do the first month together. Okay, we are going to assume that she has a carryover balance of $1,400. This is Sarah. She has an APR of 20.99%. She makes no new purchases and only makes the minimum payment each month of 6%. So we're going to complete the table. Okay, so beginning balance of $1,400. This is her carryover balance. Go ahead and first find our finance charge. So remember, decimal to or percent to a decimal, divide by 12, and multiply by the 1,400. $24.49. Very good. Okay, so your finance charge is added to your beginning balance. So to find the new balance, we're going to add these two together, and they will equal the new balance. So 1400 plus 2449 gives me 1424.49. All right, I just added across. Now your minimum payment in this case is 6%, but that 6% is based off of the new balance. So I'll take my new balance of 1424.49 and I'm going to multiply by 6%. So what is 1424.49 times 6%, or 0.06 as a decimal? 85.47. Very good. Okay, so that's the minimum payment. Now think through this logically. You owed $1424.49 at the end of the month. You paid $85.47. So how much is going to carry over to the next month? How do we figure that out? Exactly. We're going to subtract the new balance, $1424.49 minus the minimum payment, and that's going to give you my carryover to the next month of $1339.02. And then we continue on. So go ahead and do 2 more months. I want to find out what is the beginning balance of month 4. That is our ultimate goal. So I'm going to give you a minute or two. Find the finance charge, add them together, find the minimum payment, and move on. All right, so I'll give you a few minutes. Go from there. And feel free to just type the answer in the chat box when you have it. Or if you get stuck, let me know that too so we can talk about it. I'm just going to kind of fill them in. And if you have questions, let me know. I just don't want to, hopefully you're making good progress or you might be done. But if you don't know where any of these numbers are coming from, you need to ask, because I do think you have to do this in your homework. And I think you have to do something somewhat like this on the exam. So, any of the three of you that are here, any questions about any of the lines, 1, 2, 3, or 4, any of the columns or rows? Where did any of those numbers come from? Did you get those? Do you have questions? Because you will be expected to replicate a table like this. Trent's good. Christian, Kara, how are you guys? Kara's good. And good. Okay, great. So, I mean, basically, if you understand how each piece is found, I mean, you're multiplying, right? You're dealing with the percentage. And if you kind of understand how it all works, especially if you have credit cards and you've lived this life, then it's not too bad. But the big piece is, notice how in this particular example, this person has made well over $200 worth of payments, and yet the beginning balance has not decreased by $200 because you got these dumb finance charges. So when you're paying $70 in finance charges, it really puts a damper on how quickly your balance goes down. So something to be aware of in terms of credit cards. All right, that's section 19. Not a whole lot to it, but it is what it is. So we go talk about bad interest with credit cards, right? When you deal with a finance charge, you're giving money away. We call that bad interest. When we get section 20, we're talking about good interest. So now we're talking about maybe a savings account, a CD, some type of investment, but basic stuff. We'll get to the more difficult investments in section 22. So there are two types of interest that we're going to talk about. And the first one is simple interest. Simple interest is simple, and we don't really see it all that often. So simple interest is found by the formula I equals PRT, and you will have the same formula sheet on exam 3 that you had on exam 2. So you will see some of these formulas on that sheet if you look at it. So it's kind of important that we need to know what these letters mean. So if I'm dealing with the I equals PRT, so I is the interest, right? So if you're trying to find the interest, this is how you get there. Does anybody know what P stands for? P is the principal. Principal means it's how much you started with. So, your initial deposit, if you will. R is the rate, and the rate is generally given to you as a percent, so you'll have to change that percent to a decimal. And then T is time, and time is always given in years. And well, I shouldn't say it's given in years. Time is always calculated in years. So if I would say 6 months, well, 6 months is half of a year, so T would be 1/2. So you got to make sure you're paying attention to your time period. Okay, but that gives us interest. So if you want to know the ending balance, well, the ending balance is found by taking the principal plus the interest, right? If you're looking at your savings account, whatever you started with, plus however much interest you earned, together those would get you your ending balance. So this second piece here, you kind of have to know that intuitively, that this is good interest, it's being added to my account. So if I take the amount that I started with and I add the interest I earned, that together gives me the ending balance. All right, let's do some math. Sarah invests $600 at 2.5% simple interest for 6 years. It is important that you recognize, simple interest, because when we get to the compound interest, right, the details matter, and you will get different answers if you use the wrong interest formula. So in this first one, how much interest does she earn? What does our formula look like here? True, I equals PRT. That is totally true. I guess I should have been a little bit more specific. Let's get that formula with with numbers in it. But this is the formula that we want to use because we are trying to find the interest. So interest, my principal is 600. What would I put in for my rate? Not 0.25, right? We got to go two places. So we're going to go 0.025. What do you mean it won't let you? And then we're talking 6 years. This won't let you? It let me. Well, you have to hit the 0 button. Or maybe your computer hates you. It's possible. That's interesting. It's very interesting. Okay, so we changed to a decimal. Yeah, it is probably why. I'm sure your computer probably doesn't like you. And then when we multiply these three together, we're going to get our interest. So let's go ahead and take 600 times 0.025 times 6. And we have $90. So in 6 years with these conditions, you'll earn $90 in interest. By you, I mean Sarah. So then we go to part B and it says, what is her balance? Well, remember that the balance is how much you started with, right? Your principal plus your interest. So to find her ending balance after 6 years, well, she started with $600. The bank gave her 90. So if I add those together, her ending balance is $690. So you do have to be careful that you're paying attention to what you're finding first and then kind of going with it. Because in each of the formulas that we're going to deal with today, like in this case, we have the interest formula and we have to know from there how to get the balance. And you're going to see how this kind of works in a different way also. Okay, I want you guys to try number 5, parts A and B. Feel free to just throw the answers in the chat box when you have them. Again, interest and balance using simple interest. How we doing? Interest, 420. So the balance is found by taking the principal plus the interest, which is 2420. Very good. And that, my friends, is simple interest. Okay? So not too bad, right? You multiply and you add. Those are kind of the pieces that you would need to answer these questions. Well, it's not very practical, right? Simple interest is just not found in too many parts of the world. So we get into compound interest. So compound interest is in your packet. If you go through it, you will see two different formulas in this section, and essentially they're the same thing. So I just kind of want to talk about it as one big formula. So we have B equals P, 1 plus R divided by N raised to the N times T power. And I often put these in parentheses as well. Now, we know what P, R, and T stand for. We saw those in the last formula, right? Principal, rate, and time being in years. And the B is the balance, so that's the same thing that we've talked about as well. The new piece here is N, and N stands for the number of times we compound in a year. So the difference between simple interest and compound interest is that simple interest is calculated only off your initial balance, period. That's it. Whereas compound interest, every time you compound, what that means is they will calculate the interest that you earn for that time period, and then they add that onto your balance. So your balance continuously gets bigger. Well, if you have a larger balance, you're going to earn more interest. So if you compound twice a year, then after it compounds the first time, that's the new balance that your interest is calculated on the second time. If you compound 12 times a year, that means 12 times a year your balance is growing. And so your balance grows, which means you're going to earn more interest every time. So it doesn't take a rocket scientist to realize that the more often you compound, the bigger your balance is going to get because it's going to grow quicker. And as your balance grows, you're going to earn more interest. So N is the number of times it compounds in a year. So just to kind of think through this, if we compound annually, well, annually means once a year, so N would be 1. If N was 1, 1 times T is just T, R divided by 1 is just R. So if we're compounding annually, our formula becomes this, B equals P times 1 plus R raised to the T. Because when N is 1, it kind of just goes away. It's not a different formula. It's just a simplified formula of what we're doing. We can talk about compounding monthly, right? If we compound monthly, that means N is 12. If we compound quarterly, quarterly means N is 4. If we go daily, oh, I got too close to the end. That means N is 365. So for these, you really have to pay attention to the word that follows compounded. Because you need to know how often you're going to do this because it changes your value for N. And also recognize, right, N is in this formula twice. So make sure you put that value in there twice. Okay, so let's go ahead and do a couple of these. The math of this is not difficult, but if you don't know how to use your calculator, you can get some really, really weird answers. So part of this will be learning how to use our calculator. So we'll start with an easy one, I compounded annually. Assume $1,200 deposit with an APR of 3.5% is compounded annually for 4 years. Now you'll notice with the compound formulas, the compound questions, I ask for the balance first and the interest second because our formula gives us balance. And then we're going to have to work backwards to find the interest. So let's first work here on the balance. Balance equals, and we're going to start with our formula, right? So our principal is 1,200. Inside I have 1 plus, my rate is 3.5%, so 0.035. Annually, that means N is 1, so I can divide by 1, or I can leave that blank, right? Because dividing by 1 doesn't change anything. And then my numerator would be N times T, so 1 times 4. So go ahead and try to plug that into your calculator, see what it spits at you. You might have to do it in maybe pieces, but we'll start with this. $1377.03. Excellent. Did everybody get $1377.03? As you're working through some of these in your calculator, if you can't figure stuff out, if you send me a picture of your calculator, I can usually give you keystrokes via email because I know most calculators and how they work. Okay, so 1377.03 is the ending balance. If we know we started with 1200 and we ended with 1377.03, how do I figure out how much interest was earned? We know the beginning, we know the end. How do I figure out the interest? Yeah, exactly. We're going to subtract. We're going to take the ending amount and subtract the beginning amount because the difference between those is the interest. So 177.03 would be the interest. It's just like our simple interest, except remember the simple interest, we found the interest first and we added it to the beginning, whereas in this case we're finding the end. So the difference between the beginning and the end is the interest. So yeah, that's all it is. Okay? Any questions about that one? Those are usually the easiest ones in terms of punching into your calculator. So let's get to one where our n is a different value. All right, so assume a $2,000 deposit compounding monthly for 8 years with an APR of 1.5%. If it's compounding monthly, what does that tell us? N is 12, exactly. So balance is principal 1 plus 0.015 divided by 12 raised to the 12 times 8 power. For some of you, you might find that it's easier, like 12 times 8 is 96. So sometimes it's easier to multiply that first before you put it in. sometimes it's easier to do this division first and get a different number. If you do that, sometimes you round, which can make your final answer a little bit different. So if you are going to do that, you want to take your decimal out as far as possible so that you can be as exact as possible. The answer should be 2254.82. So if you're getting, Kara, something raised to the, you need to take, based off your answer, you have to make sure that you're taking this piece inside the parentheses. That is what's being raised to the 96th power. The last thing you do is multiply by 2,000. So it's 2,000 times this piece. So if you have to do it in pieces, you want to make sure that you do the inside, get an answer for inside the parentheses, then raise it to the exponent, then last step, multiply by 2,000. Yeah. So hopefully Trent and Christian, are you guys getting this in your calculator okay? Yeah, good. Because the math behind it isn't hard. I mean, as long as you know what the pieces of the formulas are, it's pretty easy to write it down. But it's making sure that you have the buttons in the right order. We're going to take our ending amount of 2254.82. We're going to subtract our beginning amount of 2,000, and that's going to give us 254.82 for the amount of interest. All right, we're going to do one more of these because I think it's important that we know what where the numbers go, how to type them all in, all that fun stuff. So a deposit of $600 with an APR of 4% compounded quarterly for 30 years. So go ahead, balance and interest, and we'll go from there. $19.80.23 is the correct answer. Quarterly means 4. So then what does that make our interest earned? Forgot the 0. 13.80.23. Subtract the end minus the beginning gives you the interest. All right, questions on the interest, simple or compound? And it really is true that the more you do these and you get comfortable with your calculator, that's really what it is with these. If you don't have the calculator with you that you're going to be using on the exam, I definitely recommend doing some of these where you know the answer. Like, so this answer is 19.80.23. get the calculator that you're going to be using for the test and try that problem because you know what the answer is. It does you no good to try a problem that you don't know what the answer is because you won't know if you know how to use that calculator. So you always want to try out a calculator with a question where you know the answer, because then you know whether or not you can use your calculator. Okay, any of you have questions over simple or compound interest? Okay, the last part of this section, of section 20, is the rule of 70. And this is sometimes called the rule of the doubling rule. So it's kind of the key here is doubling. If something is growing at an annual rate, so it could be compounding annually, or it could be population growth, or the growth or the increase in the number of rats in your basement. It can be anything. But if something is growing annually, you can use the rule of 70 to approximate how long it will take to double. And the formula is 70, well, that's a big 70, divided by P, where P stands for the percent as a percent. And this is an approximate, and this gives you the number of years. Okay, and it doesn't matter how much or how many. If you take 70 divided by the percent, you will get an approximate amount of years it will take for something to double. So let's put that into practice. How long will it take for money, it doesn't matter how much, to double if the APR is 5% compounded annually? Since we are talking about doubling, growing annually, we take 70 divided by the percent. The percent is 5. So what is 70 divided by 5? 14. Exactly. So if this is your issue, you're putting money in a bank, the APR is 5%, wouldn't that be amazing? And it's compounded annually. In 14 years, your money will double. If you started with $10,000, it'll double to $20,000. If you started with $5, it will double to $10. The amount doesn't matter because we're talking about percentages here. And that's basically the rule of 70. So go ahead and try this one. The population of the U.S. increased at a rate of 1.6% as of the time in 2016 when I did this one. How long before the population doubles? And you can round to the nearest whole number if you'd like. Yeah, 44 years. We're talking, usually the growth rate of populations is annual growth. So we take 70 divided by 1, and you know you're going to do this because of the doubling factor here. So 1.6, which gives you 43.75, which is roughly 44 years. If that continue, I mean, and that assumes that you have the growth rate of 1.6 every year. But that's crazy to think about. In our lifetime, potentially you could see the population double in this country. It's the growth rate has slowed since then, I believe, but still kind of crazy. Okay, so that's the rule of 70, or the doubling rule. One thing to just throw at you, if something talks about quadruple, quadruple means doubling twice. So if they talk about how long would it take for this population, this question number 10, before the population, if it said quadrupled, well, that just means doubling twice. So if it takes 44 years to double, well, multiply that by 2, it would take 88 years to quadruple, because it would double again, if that makes sense. So quadrupling simply means doubling twice. And I tell you that because you're going to do a web work problem, and they're going to talk about quadrupling. So there's that. So that's the rule of 70, not too bad, and that's section 20. So we are then going to hit up section 21, which is in a different PowerPoint, obviously. So section 20, and we got a different background, so we're going to keep you, on your toes here. So section 21, we'll get done here in a few minutes. But we're going to talk about loans. So house loans, car loans, boat loans, pick a loan, any loan. But we are getting into Excel formulas. So we will do 3 total Excel formulas, 2 in this section and then 1 in section 22. And they all have the same guts, right? The same inside, basically. It's just the outside that's different. So, math people are not creative. So PMT, if you're trying to find the payment, so if you want to find the payment, you would use the PMT function. PV stands for present value. So when you would use the first one, the PMT function, I want to buy a $400,000 house. How much will my payments be? Okay, because amount borrowed, if I'm going to borrow $400,000, that would stress me out. I can work backwards and find out my payments. Or you can work the smart way and say, I know I can afford a $700 rent payment, so I can make a house payment on that. If I know I can make a $700 payment, what is the value of the house I can buy? The present value of a house. So the beginning piece is the PMT or the PV. It tells you what you're looking for. And that's how you know what to do. So we'll kind of talk through this a little bit. All right, so let's jump in. Stacy wants to buy a $220,000 house. She has a 20% down payment, 4% interest rate, and a 30-year mortgage. All right, so first things first, she's going to make a down payment. The house is $220,000. She's making a 20% down payment. How do we figure out how much the down payment is going to be if it's 20%? Anybody have an idea on that one? It's $220,000 house. Yeah, exactly. So we're going to take the price of the house, $220,000, and 20% of that is the down payment. So times 0.2, which gives us $44,000. All right, chump change. Don't we all have $44,000 in our pocket? Yeah, of course. So her down payment is $44,000. Well, if she makes a $44,000 payment, how much is she going to borrow from the bank? How do we figure that part out? The down payment is what you paid. Exactly. The down payment is what you're paying up front. So if the house total bill is $220,000 and she's paying $44,000 up front, the borrowed amount is everything else, which is roughly $176,000. Because when the bank is figuring your payments, the payments are not, they're based off of the amount that you borrow, not the amount of the house that you buy. So if you put $44,000 down, your payment does not include that $44,000 you already paid. So when we get to letter C, what would you type into Excel? Well, I'm trying to find monthly payment. So I'm going to use the PMT function because whatever I'm trying to find is what goes out front. Now, the first part is the interest rate. It's 4% interest rate. But again, we're making monthly payments, not yearly payments. So I'm going to take my interest rate. I'm going to change it to a decimal because that's what my brain is trained to do. And I'm going to divide it by 12 because I'm making monthly payments. The middle piece is how many payments you're going to make. Well, I'm going to make 12 payments a year because there's one every month. And I'm going to multiply that by the number of years in my mortgage. So I put 12 times 30. You could just put 360 if that makes you happier. But remember that Excel is a calculator. So Excel can do all of these divisions and multiplications. And then at the end is the total amount that I'm borrowing, which is $176,000. Notice there's a negative sign in front of $176,000 because you're borrowing that money, right? That money is leaving you. And there's no comma in that number. There should only be 2 commas in your formula, and that's between sections. So the first part is your interest rate monthly. the middle is the number of payments, and the piece at the end is the amount that you borrowed. Now, if you type that into Excel, you will get $840.25. So if this is your world, your house payment is going to be $840.25. Great. Any questions on that? Okay, then let's look at letter D. Assuming that Stacy makes the minimum payment only every month, she has it directly taken out, $840.25 every month. How much will she pay total for her mortgage? And how do I figure that out? And don't say $176,000 because that's wrong. That's the amount that she borrowed, not the amount that she pays back. Because remember, you have to pay interest on these loans, 4% actually. So anybody have any idea how we figure out how much we're going to pay every month, or over the life of the mortgage? Excuse me. We know we're paying $840.25 a month. Anybody? If you're paying $840.25 per month, and you make that payment 12 months a year, and you're doing that for 30 years, this will give me my total payback. So monthly payment times 12 months in a year times the 30 years in our mortgage. If we do that, Stacy will pay back a total of $302,490. How do we figure out how much total interest she paid on that house? Subtract by the amount she borrowed. Exactly. Absolutely correct. So if this is her total payback, $302,490, and she only borrowed $176,000, well, the difference between what you borrowed and what you paid back is the interest. So in this case, she paid $126,490 in interest, which is a lot of money. I mean, you can buy a really nice house for $126,000. But that's what happens when you only make the minimum payment. So even if she would just round this $840.25 up to $850, anything you pay over the minimum payment comes directly off the principal. And the faster your balance goes, it's just like with a credit card. The faster your balance goes down, the less interest you're going to pay. So my aunt is a loan officer at a bank, and when my sister bought her house, my aunt told her, now she had a 30-year mortgage, she said, if you pay an extra $100 a month, you will cut 7 years off your mortgage. So my sister did that. She's got a 30-year mortgage. She's paying it off in 23 years by paying $100 more every month. Some months that's pretty tight, but she can do that. It saves her a ton of money in interest because that extra $100 a month comes straight off the principal. Okay. All right. I want to look at. Okay. So we're going to jump to number 3 here. Tom can afford his rent of $700 easily and decides he wants to spend the same amount each month on a house payment. Assuming bank agrees to a 3.9% interest rate on a 30-year mortgage, how much of a house can Tom afford? So this is not taking into account insurance or property taxes. But you can see that now he's trying, how much house can he afford? So now he's talking about the present value. We're looking at PV. But I just kind of want, because this is an Excel problem, I kind of wanted to talk about this as we're nearing up the end here. You still start with your interest rate, so 0.039 divided by 12, where it's a 30-year mortgage. So if he makes 12 payments a year for 30 years, that's the number of payments in the middle. And then at the end is the amount that he can afford. So he's paying $700. Again, it's negative because you're paying that money, right? So you type that into Excel, and I think if you type that into Excel, I think the answer is 148,409.41. So he could roughly afford a $150,000 house. And, you know, when I was thinking about buying a house a while ago, you know, I did this, and I went to Excel and I kind of punched this stuff in just to kind of get an idea of what I want to look for. Because the last thing you want to do is fall in love with a $300,000 house and then realize you can't afford a $300,000 house, right? So it's better to start with what can you afford and kind of work from there. So always good to know. Always good to know. Okay, there's only one more piece of this section, and it's the total expense ratio. This kind of, the bank does something kind of like this when they figure out what they're going to allow you to borrow. So a generic version of this is 36% of your monthly gross income minus your monthly home bills. So that's property taxes and insurance. And then subtract your other monthly bills. So if you know that you spend $300 a month on a student loan, or every month your credit card it's always $200 for what, I mean, any regular monthly bills that you can put in here. Because you don't want to be house poor, meaning you can afford your house payment, but you can't afford anything else. So you have no furniture, you have no electricity, because you can't afford those things. So you want to make sure that you have those kind of things punched in, and then you can still make figure out your monthly payment, right? So this is a way to figure out what kind of payment can I actually afford based off of how much money I'm earning. Okay, so let's do a problem like this, then we will call it a day. So I don't know why this is cut off, but Bob earns $40,000 annually. The area he's looking to buy is property taxes of $1,000 a year, and he anticipates $800 a year for insurance. He has a $350 monthly car payment, and he pays $80 a month for a gym membership. Okay, so the piece that we really need up here is the $40,000. Okay. Oh, I lied. It's $48,000. I just found my paper. So Bob earns $48,000 annually. That makes the math a little bit nicer. Okay, so if we're thinking about the total expense ratio, we start with 36% of his monthly gross. So 0.36. We know that he earns $48,000 a year, but that's annually. So annual divided by 12. So if we take 48,000 divided by 12 is 4,000. 4,000 times 0.36 gives me 1440. So the 1440 is kind of your starting amount, right? This is your 36% of your monthly gross, and now we're going to take out all of this other crap. So you'll notice that property taxes are $1,000, insurance is $1,800 or $800. So that's $1,800 in house bills, right? But that's annual. So we want to divide those by 12. So Bob is going to pay $150 a month in house stuff, right? Insurance and taxes. Usually that's escrowed in, but we still want to kind of keep that in mind. And then the last piece is monthly bills. So he has a $350 car payment and an $80 gym membership that he's not getting rid of anytime soon. So we're going to subtract the $430 for the regular monthly bills he knows he has. When we do that, we would find out that Bob can afford a house payment of $860 based off of our total expense ratio. And then you can say, okay, if you go to part B, if I have a 4% interest rate, well, that's 0.04 divided by 12. He's looking for a 20-year loan, 12 months in a year, times 20 years, $860 payment. How much of a house can he afford? And based off that, $141,918.80. And again, you have to do this in Excel. Your calculator will not do this. Okay. So that was kind of a little bit of a rush job there in section 21, but overarching the big ideas. So you can always watch the videos that go with the packet to make sure that you have a firm grasp on those if you need a little bit more guidance, right? You can find those in WebWork or in other spots in the course. But does anybody have any questions over any of the sections, 19, 20, 21, before we call it a day? Oh, Kira's good. Okay. Well, I thank you for your attention and your work. I appreciate that as always. So you've got 3 sections to work on, the quiz, the Excel assignment, the discussion board. I will post the video that goes with the Excel credit cards assignment. And we'll go from there. Yeah, again, no class next week because it's Thanksgiving break, so have a good week off. And I will see you 2 weeks from today with the next couple sections. So, yeah, and I will be posting a video to go with the 3rd project, introducing that. So if you want to get started on that over the break, you can, but you don't have to. So have a great day. Enjoy whatever it is you do. And I'll be available via email if you have questions. So let me know how I can help. Other than that, thanks for coming. Talk to you later.